Hey there, CJ Math students, and welcome to Notes 3.5 Part 1. So today we're working on proportions, and two variables or two numbers are proportional if a change in one number is always accompanied by a change, running out of space, in the other. All right, so basically we have to be able to say that the rate of change between these two numbers stays the same the exact same time for it to be proportional. So let's take a look at these proportional relationships that I found. So we have one number, we'll call it x, and another number y. And when x is 1, y is 3. And notice when x goes up to 2, y goes up to 6. And when x goes up to 9, y goes up to 27. So hopefully you can see that the multiplier between these two variables is just 3 the entire time. And I know it's going to be difficult for you to write that on your paper since it's all dark, but if you can, it's basically just 1 times 3 gives you 3. 2 times 3 gives you 6. 9 times 3 gives you 27. So notice that the change in them is proportional. So if you put y over x, you'd have 3 over 1, which is 3, right? 6 over 2, which is 3, and 27 over 9, which is 3, right? So that multiplier of 3 stays constant. It's proportional. Notice, however, if I change this last value, 1 to 3, 2 to 6, right? These are all times 3. But then 10 to 35, this is times, I don't know, 3.5 maybe, right? So let's do B to A. Are they proportional? So the ratio is 3 to 1. Well, that's 3, right? 6 to 2, that's 3. But 35 to 10 is not the same, right? It's 3.5. So these are not proportional because it does not have the same constant rate, constant multiplier throughout, right? So let's take a look at this first problem. Is it proportional? That's what we're trying to figure out. So a movie theater charges $10.50 per ticket and $5 per bucket of popcorn. You never buy the popcorn because you think it's too expensive. Is the total price you pay proportional to the number of tickets you buy? So look, we're just looking at total price we pay and the number of tickets we buy. All this popcorn stuff, this is nonsense. We don't even need it, right? So let's pretend we bought one ticket. How much would it cost us? It would cost us $10.50. If we bought 2 tickets, well, that's $20.50, so $21, right? Sorry, 50 cents and 50 cents. If we bought 3 tickets, it would cost us, again, you're just adding $31.50. So basically, we have the same multiplier the entire time. It's just times 10.50, times 10.50, times 10.50. So yes, in answer, yes, they are proportional, because we have the same multiplier, right? And we could write this as the number of tickets to price. Sorry, actually, we want the opposite, right? We want a price to number of tickets, sorry. Price, because that's how we read it. Total price proportional to number of tickets. So it's price to tickets proportional, yes. And we can say it's 10.50 or 10.5 to 1. All right? Let's take a look at another one. Today, Nate has 100 bananas. He will eat 2 of them every day. Is the number of bananas Nate has left proportional to the number of days passed? So we got the number of bananas left to the days that have passed. So in one day, if I do 100 and he eats 2, right? So minus 2, he'll have 98 bananas left. Right? After 2 days, remember he only has 98 now, so 98 minus 2, he has 96 left. After 3 days, he has 96 minus 2, which is 94 left. All right, so think about this. This seems like it's proportional, right? Because we're just going down by 2 every time. But again, bananas left to days past. That's 98 over 1, right? How did I get that? Bananas left to days past. Bananas left to days past. 98 over 1. So that equals 98. But then we have 96 over 2 on the next one. And 96 divided by 2 is 48. So wait a second, those aren't proportional because that's not the same rate. And then we have 94 divided by 2. And 94 divided by 2 is 47. So look, we have a jump here of 50, but then just a jump of 1. So this is plus 50 or plus negative 50, and then this is plus just 1. So this is not proportional. It's not the same rate the entire time. Not proportional. Okay. Last one here. It says the following table describes the relationships between the number of servings of spaghetti bolognese and the number of tomatoes needed to prepare them. Test the ratio for equivalence, determine if it's proportional or not. So let's see. We have 6 to 10, 9 to 15, and 15 to 25. So we want to test the ratio to see if they're proportional. So 6 to 10, 9 to 15, and 15 to 25. So 6 to 10 can be simplified by dividing by 2. And what do we get? We get 3 to 5. 9 to 15, we can simplify divide by 3. What do we get? Oh, we get 3 to 5. Okay. And 15 and 25 can be simplified by divided by 5. And what do we get? We get 3 to 5. So look at this. They all have the same multiplier. They all have the same ratio of 3 to 5. Same ratio. So they are proportional. You can just put yes over there. So that's the end of part 1.